Thank you very much. My name is Henric Rhedin. I represent SHT Sinterma. We provide efficient cooling for electronics using better thermal interface materials. I won't bore you with many technical details, but what we see is that heat is a staggering problem today, in electronics in particular, but also in other applications. The internet and the Internet of Things grows. It's 2% of the energy consumption today. 5 years ago, it was 1%. It's the fastest growing factor. So I'm sorry, Liselott, we have to shut down the internet. Just kidding. But we need to take care of the energy we put into internet and make it more efficient. Just to give you a hint what the thermal interface material is, it's essentially something as boring as a layer material taking away heat from your electronic component. An Intel processor has a huge thermal problem. How to make it smaller is not the issue. It's actually getting the heat out when we make it smaller. The technology drivers we see here is that the system on a chip is coming more and more, so we have larger components. We have higher temperatures, as I said before, and we actually have to require better energy efficiency in order to solve this. So this is where our spot is. We can do this cheaper, better, and more reliable. This is an ancient market. It's been around for so long. Thermal interface materials has a 1.2 billion euros market. And thermal cooling of electronics, this is just 1/10 of that market. But it's still huge. It has a good growth. There are different segments here. We have automotive, we have avionics, we have defense, we have computers, for instance. And we have tested our material successfully and benchmarked it against the competing materials in projects with the R&D departments. Because we're from Chalmers, which is a university, which means we have excellent connections to the R&D departments, but doesn't mean that we can do the selling job and connect to the purchasing department of our possible customers. So that's our main challenge. We're going to manufacture and sell thermal interface materials on a world scale. We have, as I said, a long track record of R&D projects, but that doesn't help us to sell. It gives us an entry point to large international companies. But, I say the technology is proven. Now we just have to start selling it. And that's a bigger challenge. We already had 3 products in our product families that has been tested successfully, as I said, for different applications. So we actually have the proof in the measurement, the technology part. But then we look at the real world. What are we facing? Well, somebody wants to buy somewhere between 50,000 and 500,000 pieces per year of this material. What does this mean? We have to prove that we can produce it. Currently, we have a capacity of 100,000 pieces per year, but we're aiming at 10% of the market, which is 6 million. So how can we bridge that gap? Well, we have a production prototype machine. I doesn't call it a production machine because it's really a prototype in order to learn production and to prove that we can produce. We need to duplicate that one. So essentially what we're looking in is building relations with customers this year, scaling up production and sales, of course, next year, and then go for profitability. If we're going for 10% of the market share, this will be a slower process. Then we will be profitable in the year 2021. Strong team in technology, but a huge team when it comes to advisors with CEOs and former CEOs from our potential customers. So the challenges we have is to become a supplier. Some people say we will never be your first customer. Some people say there has to be a second source, etc., etc. You heard it. And also building sales and distribution. We have some funding in place, but we look to 450,000 euros early next year, and maybe 850,000 the year after that. And it will, of course, be for production and sales. That's the challenge. Thank you very much, and I promise you, I will not go and shut down the internet for you.